Today we're going to continue to talk about labor market marginality, and specifically we'll take a look at the marginal revenue product of labor, or MRPL, and labor demand relationship, or labor demand equation. Let's first do this by recalling that we're using the same marginal product of labor relationship leading to a marginal revenue product of labor relationship. But in this case, we're going to use two different equations, a marginal revenue product of labor equation and a labor demand equation. By the way, these equations are not similar to the ones that would create the values we've seen in the other tables in prior segments within this series. These are uniquely different from those. So they're going to give us different intercepts, different table values, etc. So let's take a look at this. I'd like to begin by actually plotting or graphing out, charting out this marginal revenue product to labor relationship. So let's think about this. We're going to have, as always, some y-axis and some x-axis relationship. And on the x-axis, we're going to look at labor, that's the quantity, and marginal revenue product of labor, since it's a marginal product times a price, is going to be expressed in currency. So we can put that on the y-axis, which is our price, our wage, or currency denominated axis. So marginal revenue product of labor here. So what we know is that this is a linear equation. It's not exponential, it's linear, it's going to be a straight line. So we can just find the intercepts on the y-axis and on the x-axis and then draw a straight line. That's going to give us that curve. So to do this, we're going to use the same premise we've always used before. If the intercept is on the y-axis, it's because the value of the x-axis is 0. So the value of L is 0 when we're on the MRPL axis. And if we're on the labor axis, well, similarly, the value of MRPL is going to be equal to 0. So let's now, in turn, set each of these variables equal to 0 to find the intercepts. So when labor demand is equal to 0, we see that MRPL is equal to 25 minus 1/2 of, well, 0, so it's minus 0, so it's simply equal to 25. And when MRPL is equal to 0, we see that 0 is equal to 25 minus 1/2 labor demand, or 1/2 labor demand is equal to 25, or labor demand is equal to 50. So we have 50 on the L, or labor axis, 25 on the MRPL axis, and we simply will give a relatively straight line to connect the two. So that's what this is going to look like. Frankly, it's downward sloping. As the quantity of labor increases, the marginal revenue product of labor decreases. That's what we would expect. So now let's think about this in context of looking at the labor demand relationship. So we're going to look at this exactly the same way. So when W is equal to 0, labor demand is going to be equal to 50 minus 2 times 0, or equal to 50. And when labor demand is equal to 0, then it's going to suggest that 0 is equal to 50 minus 2W, or 2W is equal to 50, or W is equal to 25. Well, what does that look like? On the W, or currency denominated axis, and the L axis, we are again at 25 and at 50. And since it similarly is simply a linear equation, it's just going to be a straight line. This looks relatively similar to the MRPL, which is for a reason. In fact, we know that one of the profit maximizing conditions in a competitive labor market is when marginal revenue product of labor is equal to the wage. And by competitive market, we simply mean a market for which supply of labor and demand for labor reach some equilibrium, or a market clearing level from which we've been able to identify some W star and some L star. Let's look at this a little bit further and see if we can cause or figure out how these two equations actually are the same equation. So given this relationship now, MRPL equals W, let's just substitute W into the MRPL equation for MRPL, such that W now is equal to 25 minus 1/2 labor demand. Well, we can rewrite that by saying 1/2 labor demand is equal to 25 minus W, or labor demand is equal to 50 minus 2W, which not only looks a lot like the labor demand equation here, it is exactly like the labor demand equation here, because when marginal revenue product of labor is equal to the wage, which it should be in a competitive, free-flowing market with some kind of equilibrium having been expressed, they actually are the exact same curve, and we measure them on the exact same graphics because wage and MRPL are simply some currency-denominated values.